Hello dear students, now I am continuing the chapter differential equations and exercise 9.5. Just in the previous class we have already discussed about homogeneous differential equation. So in the 12th class only there are three methods for solving differential equations, first order and first degree. First of all, we see that whether the differential equation in terms of separable variables form or in homogeneous form or in linear differential equation. First, find that dy by dx. If value of dy by dx, that is function related x and y, can be separated, the function of x is separated from the function of y, then that is called variable separable form. Then we can use by direct integration. Okay. If not separable, then just we are trying to whether the given equation is in terms of homogeneous differential equation or not. Okay, for that we know that first of all we have to find the value of dy by dx. We have to find the value of dy upon dx, that is relation between x and y. If separated, then separate. Variable separable form, if not separated, cannot be separated, then suppose the relation is what? Fx y. And if this is homogeneous function of degree 0, then this differential equation is called homogeneous differential equation of first order and first degree. Clear? Homogeneous equation of degree 0, the nth degree homogeneous function in two variable x and y, we can write in that case, if lambda x lambda y equals to lambda power n f of xy, that is in x and place of x lambda x, in place of y lambda y, just we have to put and solve it. Then if we can get like this form, then we can say the function fxy is called nth degree homogeneous function in x and y. For solution of differential equation of first order and first degree, we have to check first whether the given differential equation is homogeneous or not. Given differential equation is homogeneous equation if this is homogeneous function of degree 0. If this is homogeneous function of degree 0. Okay, fxy is homogeneous function of degree 0. 0 degree homogeneous function. If we can get like this, then we can say the given differential equation is homogeneous function, the homogeneous differential equation. Okay. And other method is if we can write fxy can be written as new function of y by x. That is a function of y by x combination, new variable y by x, function of y by x, and x to the power, here x, then x to the power n. Then nth degree homogeneous function. It is if the given function can be written like this, function of y by x, here x to the power n, then nth degree homogeneous function is this. And also if this function can be written as like this, x by y. Here y to the power n. This is an degree homogeneous function in x and y. If this function can be written either in this form or in this form, then we can say that this is homogeneous function of n degree. But for here, if fxy can be written like this. X to the power 0 means 1, y to the power 0 means 1. That is what? fxy is just like this form, y by x, function of y by x or function of x by y. Then we can say the given differential equation is homogeneous function of first order and first degree. Okay. If given differential equation, if fxy can be written like this, that is combination y by x, then we put y by x equals to what? V. If function can be written like this, x by y, then we can also write like this. Here, this means what? Here, y equals to, for this, we write y equals to vx. Here v is function of x. Here also we write x equal to vy. Vy for this case. X equals to vy. That is v is function of y also. Combination of this is taken as x. Here v is function of x, y equal to vx for this case. Generally we use this. Okay. And then y equal to this, and then we can find dy by dx equals to differentiate with respect to x on both sides. Function of x, that is what? x1 and then b plus x dv by dx. dy by dx equal to this, y equal to this. Just put dy by dx and y in given differential equation. Then differential equation will convert in terms of v and x. That will be separable form. That will be in the form of separable, variable separable form, and we can differentiate, integrate directly, and we can get value of v equals to in terms of x. Finally, we put b equals to y by x here. b equals to what? Y by x. Then we can get the solution of original equation. Okay, this is the process of solving homogeneous differential equation. So first of all, we are trying to show that the given differential equation is homogeneous differential equation. Okay, so up to question 6 was completed. Now here we can see that question 7, question 8, question 9, question 10, 7, 8, 9, 10. All the questions are having terms of y by x or x by y form. So here take questions 7. X cos y by x, solution question 7. Okay, take question 7. X cos y by x, given equation is x cos y by x, cos y by x plus y sin y by x, y dx, this into y dx. This is equals to y sin y by x equals to y sin y by x minus x cos y by x, x dy, x dy, x dy. Clear? This is given differential equation. We have to solve it. We know for homogeneous equation there is a combination y by x or x by y. Here y by x is in most of the term. So for homogeneous equation, just we have to find the value of dy by dx and then substitute x, lambda x for x and lambda y for y, and we have to show fxy equals to lambda to the power 0 fxy. Then 0 degree homogeneous function will be fxy, so given differential equation will be homogeneous equation. Okay, also we can write function of y by x, then also we can say that differential equation is homogeneous equation. Here we see that for finding dy by dx, dy, this is dx. Okay, so dy by dx means dy by dx equals to this upon this. We can write dy upon dx equals to and denominator will be dy by dx, this x cos y by x plus y sin y by x minus y upon x, here y sin y by x plus minus x cos y by x. Dy by dx, this upon this is dy by dx. Here we see that y by x, y by x, y by x, y by x, y by x. Also we can divide the numerator by x, where x cancel, y by x. Here y by x, x cancel. So in everywhere we can see that present y by x. Okay. Also in another form we can say just like this. Suppose this is fxy. Say, okay, it is fxy. We see that f lambda x lambda y equals to, in place of x lambda x cos lambda y upon lambda x plus y sin lambda y upon lambda x. In place of y, lambda y, and in place of y, lambda y. Similarly here, in place of y, lambda y sin lambda y upon lambda x minus lambda x cos of lambda y upon lambda x lambda x. We can see that here lambda common, lambda common. So lambda upon lambda cancel. Here lambda upon lambda cancel. Here lambda cancel, lambda cancel. That means what? Lambda to the power 0 f of xy. Very clear, because function is remain same as this. So we get what? F lambda x lambda y, which shows that fxy is homogeneous function of, implies fxy is homogeneous function of degree 0 or degree 0 in x and y, implies this equation 1, implies given equation 1 is a homogeneous differential equation of first order and first degree. Only write one is the differential equation. Here we see that the combination y by x. So to solve it, therefore to solve, this is the writing method. You have to write very neatly and very clearly. Therefore to solve given equation 1, we put what? Y equals to Vx. implies differentiate it on both sides. Dy by dx equals to what? V plus x into dv upon dx. Differentiate with respect to x. V is function of x. Okay. Now y dy by dx. Put these two value in given equation. Okay. For proving homogeneous equation, here we can also write by dividing it in the numerator and denominator by x. Then we can get here x is cancel out cos y by x plus y by x combination sin y by x. Here y by x sin y by x minus x cancel cos y by x, and this is y by x. So all are y by x. So we can write the fxy is as a what? A capital function of y by x, another function of y by x. That is homogeneous function. You can also write. That means fxy equals to function of y by x. That is fxy is homogeneous function of 0 degree. Okay. We can write by writing this. Now putting the values of y and dy upon dx. Y and dy by dx. Now putting the values of y and dy by dx in 1 we get. Okay, in 1 we get what? Just put the value of dy by dx and y. Okay, dy by dx means v plus x dv upon dx equals to, in place of y, dx. Here x cos vx upon x plus vx sin y means vx upon x, and also vx upon here y vx sin y by x minus x cos vx upon x. Just put y equals to dx and dy by dx equal to this. After this stage, we can see that the given differential equation is converted to a differential equation where v is the dependent variable and x is the independent variable, and which is separable form. Just see v plus x dv upon dx equals to, here get x cancel, so x common, here x common, x cancel, upper side v. So here we see that cos v plus v sin v into v upon v sin v minus cos v. We get like this. Clear? V sin v, here also vx, v sin v minus cos v, this cos v plus v sin v, cos v plus v sin v, and also v. We get this totally function of v x dy. Equation in v and x. So we can write here x dv upon dx and transfer v to right hand side. So cos v plus v sin v upon v sin v minus cos v minus v, transfer to right hand side. Now we can see that this is a variable separable form differential equation in v and x. So here by taking LCM we can solve it. Multiply it, v cos v plus v square sin v minus of this into this is v square sin v, v square sin v minus minus plus v cos v upon v sin v minus cos v. This is dv upon dx. Now we have to solve it. Okay. So after this line we can write right hand side here v cos v, v cos v, v cos v, v square sin v, v square sin v, v square sin v, v square sin v cancel out to v cos v. So just write here x is also here, implies x dv upon dx equals to 2v cos v, 2v cos v upon v sin v minus cos v. Okay. Now this is separable form. We can write like this: v sin v minus cos v upon 2, or we can take 2 by x dx here. Here v cos v with dv. We can write like this: all the terms related to v with v dv. So this go to denominator, this go to numerator, and 2 remains here, 2 by x dx. We can write like this. Now integrating on both sides we can get further result. Okay. So here we see that v we cancel. If we divide this, then what? V we cancel, sin by cos v means tan v. Tan v minus cos cancel 1 by v. This is with v and this is 2 1 by x dx. Integrating both sides, separable form. Integrating both sides, we get integrating both sides with respect to x. Integrating both sides with we get what? Integration of tan v minus 1 by v dv. Just side take integration sign 1 by x dx plus some constant c. Suppose we can take k. Okay. Suppose constant is k. Now here integration of tan v 1 by v, tan v means what? Log sec minus log cos. So log mod sec v minus log v 1 by v equals to 2 log x plus, we can take it as just take it log c, log c. Okay, for easily writing here we see that what? Log of sec v upon v equals to what? Log of x square plus log of c. Just solve it. Finally, put v equals to y by x, then we can get the required solution. So implies here log of, we can write sec v upon v minus log x square you can write right side log c into x square. Okay, we can take like this, implies sec v upon v equals to log of cx square. Now putting v equals to y by x, sec v equals to cv x square. Finally, result can be get in simplified form as, just you can write sec to cos. So cos v equals to 1 upon c v x square. We can write like this, cos, revert it. So cos of y by x v equals to 1 upon c into 1 upon y by x into x square. So you can write here, we see that 1 x cancel, so yx, so xy cos of y by x equals to xy, go to here 1 by c, we can write constant k, where k equals to 1 by c, which is required solution. Just you have to write solution is simplified form. Okay, so this is the solution of question 7. xy cos y by x equals to c, constant. Clear? So for writing here, just we put y by x equals to b, implies b, y by x equals to b, since this. Clear? This is the solution. So what is the method? First of all, just see whether the given differential equation is in the form of separable form. If not, first order first degree, then check for homogeneous differential equation. If homogeneous differential equation, then you can solve it by taking y equals to bx and do it. Okay. Now take question 8, 9, 10, all are just like y by x format. 10 is x by y. Also x by y format can be of homogeneous differential equation. So here take 8 can be also shown that homogeneous differential equation, because just I am giving hint here for 7, 8, 9. Okay, let's see what is question 8. X dy by dx, 8 x dy by dx minus y plus x sine y by x is equals to 0. This is 8, and 9 is what? 9 is y at dx, y dx plus x log y by x plus x log y by x dy minus 2 x dy equals to 0. Just like this. Okay. So whether these two equations are y by x format, our target is what? Just write dy by dx. Here dy by dx equals to what? Dy by dx is equals to this, go to the right hand side and divided by x. So what? Transfer to right hand side, minus plus and plus minus, this is transfer form, or we can write also minus x equals to 0, x, just write dy by dx. What? Dy by dx, y minus x sine y by x upon what? X, where we see that y by x divide minus x is cancel, sine y by x. This is what? fxy, which it can be considered as a function of y by x. That means what? It can be written like this, x to the power 0. Implies what? This is homogeneous function of degree 0. That is homogeneous function. Given function is a homogeneous function. So y by x, we can write y equal to vx. Y equals to what? Vx. Here dy by dx equals to what? V plus x dv by dx. Just this, substitute this in given equation. If we substitute this here, then we can see that what? Here dy by dx. dy by dx means v x dv by dx equals to, here y equals to vx. Here vx dx. Vx means x is cancel, v vx. Here vx. Okay. Here vx. So v x common, x cancel. V minus sine b. Here v minus sine b. This is both sides having v cancel. So dv by dx, so dv upon sine v equals to dx by x minus. So integrate it. Sine v means cosec v. Cosec v means log of cosec minus cot equals to minus a log of x plus of log c. Now we can solve it. Log cancel, and cosec v minus cos v, cosec v minus cot v, cosec 1 by sine, cot cos by sine, v means y by x, then you can get result. Okay. Similarly, question 9, here also just same process. You can see here. If we can write dy taking common, x log this minus 2x. Okay. So x log y by x minus 2x, coefficient of dy. So dy equals to, means this is go to the numerator, denominator, and here x y by. There is dy upon dx. dy upon dx equal to this, but here minus sign, because in this term y dy and this term x. So transfer to right hand side, that means minus y. Okay. Now we can see that here, if we divide numerator here, we can prove it. How? Take x common, then we can write y by x. The total function is what? Y by x, y by x. That is homogeneous function. And function of what? Function of y by x. So homogeneous function. So we can write y by x, y equal to vx means y by v equal to y by x. That is minus v upon log v minus 2. So here dv upon dx, dv by dx into x plus v. Transfer v to here. This. Now we can convert it in terms of v and x as its variable separable form. Solve it and put the value of v. So 9 is also homogeneous equation, and you can solve it. Here 10 is also 1 plus x by y, 1 plus e to the x by y, 1 minus e to the x by y. Take question 10. Given 1 plus e to the power x by y, e to the power x by y into what? Dx plus e to the power x by y 1 minus x by y equals to 0. 1 minus x by y dy equals to 0. Here dy equals to 0. This is equation 10. It can be also solved because from here we can write what? Dy by dx. Dy upon dx equals to what? Transferring minus sign can be adjusted by taking x by y minus 1. So, what? X by y minus 1 e to the power x by y 1 plus e to the power x by y. You can write it now. This is equals to this with minus sign. Minus can be adjusted like x by y minus 1. So that is the coefficient of dy. So divided by that part to this. This is fxy. It is in the form of what? Function of x by can be written as, that is fxy can be written as is equals to fx y, which can be written as x by y, just like this. Y to the power 0 function of x by y implies fxy is homogeneous function of 0 degree in x and y, implies given equation is homogeneous differential equation. Given equation is homogeneous differential equation. Okay, so to solve it, put what? Here, what we can put? X equals to v y. X equals to v y. Clear? Sorry, x equals to v y. Well, v is function of y. So implies differentiate with respect to y. We can solve this equation by putting x equals to vy. So here x equals to vy, where v is function of y, so differentiate with respect to y, so we can get dx upon dy equals to what? This is equals to v plus y dv upon dy. Clear? This dx by dy. Okay, so here we can write this as dx upon dy equals to x by y minus 1, just revert it, e to the power x by y upon 1 plus e to the power x by y, implies just put the value of x and dx by dy. dx by dy means v plus y dv upon dy equals to x by y equals to, here see, x by y equals to what? V. So x by equals to v, so v minus 1 e to the power v upon 1 plus e to the power v. Clear? Now y dv upon dy, v transfer to right hand side, v minus 1 e to the power b upon 1 plus e to the power b minus b. Now taking LCM, we can see that e to the power b, here b multiply it, b e to the power b minus e to the power b minus b minus b e to the power b minus b minus b e to the power b upon this. Okay. So y dv upon dy. Now this is equals to just we can solve it. Here we see that y dv upon dy. This differential equation in v and y separate from. Here v to the power v to the power v cancel, minus of v plus e to the power b upon 1 plus e to the power b. So write it like this: 1 plus e to the power b upon b plus e to the power b equals to minus 1 upon y dy. Clear? Now solve it. Okay, we can solve it. How? Separable form. Here dy dv equals to minus of this. Here minus 1 of this. Now integrate it. Integrating just like v and x and v and y. Okay, so integrating on both sides, we get what? Integration of 1 plus e to the power v dv upon v plus e to the power v equals to minus of integration of 1 upon y dy. Clear? This we can see here. If we put this, put v plus e to the power v equals to t, then we can differentiate it. 1 plus e to the power v dv equals to dt. That is what? This is dt. dt by t log t. That means what? Differentiation. Integration of dt upon t equals to minus log y plus of log c. Suppose one constant, you can write here constant log c. Clear? This, or you can write constant after integration like this, constant, just like this. Okay, so here see that what? Log t. T means we can write v e to the power v is equals to log of c by y. We can write like this: log c by y. What? Log c minus log y. Log a by b, log c by y. This. Now after this line, just we have to solve it to the end. Here log, so v plus e to the power v equals to c upon y. Now v means x by y equals to v. So here v equals to what? X by y. So x by y plus e to the power x by y equals to c by y. So we see that what? X plus y to the power x by y equals to c, which is required solution. Okay, here taking LCM, y go to here, so x plus y e to the power x by y equals to c. This is the solution of question 10. Okay, so 10 y e to the power x by y plus x, y e to the power x by y, y e to the power x by y, y e to the power x by y plus x equals to c. Clear? So this is the process of solving homogeneous differential equation. Okay, so you can solve the questions, and next part is finding particular solution. You know what is the meaning of particular solution? Just finding constant by given condition, using condition. Here take question 11. Okay, question 11 is what? Here we have to find a particular solution. That means after solving we have to find constant, value of constant by using condition. Here x plus y dy, x minus y dx equals to 0, y1 x1, given x plus y dy plus x minus y dx equals to 0, y equals to 1 when x equals to 1. This is given. Y equal to 1 when x equal to 1. Clear? This is the equation. Given equation is this, and this is the given condition. We have to find particular solution. We have to find particular solution. So just try to solve as homogeneous equation, because here we can write dy by dx. First of all, we have to solve this as and finding general solution in terms of constant, and finally by using this condition we can get the value of the constant and find the constant and put the value of constant to the general solution. Okay, here dy by dx equal to what? Dy by dx is equals to minus x minus y upon x plus y. We can see this is homogeneous equation because it can be written as how? fxy. This is fxy, function of xy, and this can be written how? By taking x common. We can write minus 1 minus y by x, 1 plus y by x. Okay, here x common, x is cancelled, x to the power 0. So it can be written x to the power 0 function of y by x as what? X minus 1 minus y by x upon x 1 plus y by x. If we take common x, then we can write like this. And this is what? The given function. This can be written in terms of, that is x what? X to the power 0 and f y by x, function of y by x. So implies fxy is what? Fxy is homogeneous function of 0 degree. Implies given equation is homogeneous differential equation. So put what? Here y by x, so y equal to bx, so y equals to dx. Implies dy by dx equals to what? b plus x dv by dx. On substituting the values of y and x, y and dy by dx in given equation 1, we get this equation 1 here, but we can say like that. Okay, here implies what we get, dy by dx v plus x dv by dx in place of this y dx minus x dx upon x plus bx. Here v plus x dv by dx equals to what? X cancel, x dv by dx equals to here minus 1 plus v upon v, 1 plus v minus v implies x dv upon dx equals to minus 1 plus v minus v square upon 1 plus v. So we see that x dv by dx equals to we cancel minus 1 plus v square upon 1 plus v. So it can be solved now by using variables as separable form. Okay, so solve. With minus sign, so here minus 1 by x dx and 1 plus v upon 1 plus v square dv, separable form. So integrating on both sides, we get what? Integration of 1 plus v upon 1 plus v square dv equals to minus integration of 1 by x dx. We can clear? Now implies plus, suppose constant k, here integration of 1 upon 1 plus v square divided into parts dv plus integration of v upon 1 plus v square dv equals to minus of log of mod x plus k. So here we see that what? Tan inverse v plus, if we put this as t, put 1 plus v square equals to t, so implies 2v dv equals to dt. So v dv equals to dt by 2. So here 1 by 2 integration dt upon t equals to minus log of mod x plus constant k. Here we see that 2 tan inverse v plus log of t means what? 1 plus v square. 1 plus v square equals to minus 2 log of mod x plus k. Okay, so finally we solve it just like this. Implies here 2 tan inverse v log 1 plus v square. Here we can see that log x to the power minus 2. So k constant, we can write like this: log 1 upon x square plus k. Clear? Implies 2 tan inverse v equals to y by x. So y by x, tan inverse y by x plus log 1 plus y square upon x square equals to log of 1 upon x square plus constant k. Clear? Now solve it. Here we see that 2 of tan inverse y by x plus log of 1 plus minus log of 1 by x square equals to k. So 2 tan inverse y by x plus log a minus log b, log a by b. So log 1 plus y square upon x square upon 1 by x square equals to k. So here by taking LCM, 1 by x square cancel, x square plus y square. So we see that 2 tan inverse y by x plus log x square plus y square equals to k. This is the solution, general solution. Okay, this is general solution. Now, when x equals to 1, y equals to 1. Y equals to 1 when x equals to 1. Now when x equal to 1, y equal to 1. So we get x and y 1. Here 2 tan inverse 1 x equal to 1 by 1 plus log 2 x square 1 square plus 1 square 2 equals to k. So here we see that k equals to tan inverse 1 means pi by 4. So from here we see that k equals to pi by 4, pi by 2. So pi by 2 plus log of 2. Log of 2. This is the value of constant. Now put the value of constant in 2. Finally, our particular solution will be, this is the general solution too. Particular solution, by using this condition, we get value of constant and put the constant in general solution. Finally, putting the value of k in 2, we get particular solution as, just put the value here. We can write log x square plus y square plus 2 tan inverse y upon x equals to constant pi by 2 plus log of 2. Okay, so this is particular solution. Question pi by 2 log 2 tan inverse y. Okay, okay, which is the required solution. Which is required solution. Clear? So this is the solution. Now, if we can see that 12, 13, 14, 15, all are 12, 13, 14, 15, all are just like y by x format, and using condition you can get the value of constant. So solve from yourself 12, 13, 14 and 15. Okay, and 16 is homogeneous, 16 is objective type questions. 16 differential equation dx by dy equals to function of x by y. So our substitution will be what? X equals to by. X equals to by. See. Okay. Simple objective question. And question 17 is also which of the following is a homogeneous equation. So see first question, 4x plus 6y plus 5. Here 3y plus 2x plus 4. Divide this two polynomial will be divided in fxy. So this is not homogeneous function because they are a constant function. So not homogeneous. And second, xy and x cube y cube, not homogeneous. Third, x cube x square and xy, not homogeneous. In question D, you can see that dy by dx equals to what? Minus y square upon x square minus xy minus y square. So D is homogeneous function. Very clear. Fxy equals to what? Minus y square upon x square minus xy minus y square. So second degree everywhere. So you can check it by putting lambda x lambda y in place of x and y, and you can get lambda equal to 0 fxy. So D is the answer. Okay, 16 and 17. And you have to solve 12, 13, 14 and 15. Same type of questions because we have already done 7, 10. Clear? So this is the complete of the exercise 9.5. Okay, so you have to do question 8, 9, 12, 13, 14, 15. Okay, from yourself. And send me PDF file of solution of at least 3 questions for your attendance. Okay.